cinematic.
I'm getting dizzy while watching.
Okay, so what I've done is I picked out some, whoops. Be good if I had my notes on. I picked out a bunch of things from the beginning of the semester all the way up until we got to the end of, I think it was like week 11 or week 10. So to start with, here's the first one. I'm on PowerPoint. I'm covering these PowerPoints right here. Chapter 8, Chapter 9, Part 1, Chapter 2, Part 1. I'm sorry, Chapter 9, Part 2, and Chapter 10, 11, PowerPoint. So those 4 PowerPoints. The first slide we're starting on from Chapter 8 PowerPoint's on slide 9. So I'm really highlighting some important slides. The reason 9 is important is because we've studied, this is the 3 areas we studied when we were at the beginning of the semester. It was doing confidence intervals for the mean when the standard deviation for the population is known, and when the population standard deviation is unknown, we're given the sample, and then proportion. So this was the beginning of the semester right here, week 1, week 2, and week 3. And that was mostly what was on the first quiz. So, let's see. Here's the equation for a confidence interval when the population standard deviation is known. That's the key equation right there. So this is slide 10. But here's the deal, if you don't forget, in your notes somewhere, I put this key equation in words, such as the mean plus and minus the z, which is the test statistic, times the population standard deviation, which is given, over the square root of the sample size. So if you're changing that to words, match that up with your notes. So right now, we're doing the first one, population mean with the standard deviation known, confidence interval. There's the key formula right there. As for an example, if you're saying, okay, what would be an example of this? Because I have a problem in front of me that I believe is asking for a confidence interval, that I believe the population standard deviation is being given. Well, the first example I found was from week 1 homework. So on this case, right here, let me open this up, let me make it bigger. Number 6C is a perfect example of a confidence interval where you had to use Z because you were given the population standard deviation. If you notice, the question said the mean is 78.1 that you had to make the confidence interval for. It gave you 90% confidence, which we had to find our, and on the PowerPoint, we just had to look it up, by the way. There's another important slide. Maybe I should bring that up. This is another important slide that I didn't have on my list. Slide 12 has all the confidence interval Z values from the table. So you don't have to use the table. You don't have to even use Excel. Just look right here when it comes to a confidence interval, and you had to use Z. So that's where the 1.645 right there, 90% confidence, where's my pointer? Hang on. 90% confidence, 1.645. Go back to this problem right here. There it is, 1.645 times the standard deviation given in the problem, if we read it, is 4.5. The sample size is 50. This is a perfect example. And you just had to come up with the lower and upper interval. That's it. And this is a perfect example from week 1. Now, look at all the things I skipped. You can pretty much say to yourself, okay, what about all this other stuff? Well, all this other stuff wasn't as important as doing a confidence interval itself. All that other stuff led to, okay, how would you come up with the Z? You know, da 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 da. Go ahead, Mom.
So for these, I have in my notes confidence.t for the Excel. Is there a difference between?
No, here I put 1, 2, 3, 4. These are the 5 main Excel formulas. At week 1, we did use dot. Which one was it? Dot.
Confidence.t.
Oh yeah, the confidence. I forgot about that. She asked about that as soon as she came in here too. And I said, look, when I was putting this review together, I forgot all about that. but don't skip it. Don't skip it because that was important.
Well, if you forgot,
but I don't have it prepared for the review.
If you forgot it here, then you probably forgot it for the exam too, right?
That's fine, it's okay.
Well, I can honestly say I forgot it for the first half, that's for sure. The second half isn't finished yet. So make sure you study it. Let me repeat what he just asked about. It's that Excel confidence, that Excel expression confidence where it helps you find the upper and lower using Excel. Do study that. Okay, now back to where we were. Here are the 5 Excel equations. Here are your p-value equations. Here are your critical value equations. I want to refresh your memory. These two, if you're using Z, you would use the 1 minus in front if your test statistic is positive, and you would use no 1 minus in front if your Z test statistic is negative, if it's negative. They're both 0, 1, 1, but if you do this p-value before a Z, you gotta multiply it times 2 if it's two-tailed, and you gotta remember to do that. That's the key to this one. So there's p-value with a Z. Here's p-value with a T. There's T, D-I-S-T, no dot. I didn't even put the notes here when to use the dot, that's if there's a negative. Instead, I said just drop the negative symbol and forget about the dot. The test statistic, you drop the negative symbol, degrees of freedom, and then you put a 1 or a 2, depending if it's a one-tail or two-tail. This is all you need are these three to do p-value for any of these, but you gotta remember, when we get to hypothesis testing, we're still on confidence interval the first 3 weeks. Week 4 forward was all hypothesis testing. And when we get there, you gotta say to yourself, you gotta know how to do p-value, or use critical value approach, or use confidence interval approach. And all 3 approaches you gotta be prepared for any of those hypothesis testing, except for there was one I said, we're not doing Z, where they were coming from the same thing, where they were similar or related ones, which we'll talk about in a minute. So meanwhile, here's your critical value approach Excel equations. If it's Z, it's norm dot S dot IMV, and what goes in here, if it's a one-tail, is the confidence. What goes in here if it's two-tail? The confidence plus half the significance. This is if you're trying to find a critical value, which, by the way, we could have used to find this critical value right here. This was a Z, 90% confidence. So is it one-tail or two-tail? It's a confidence interval, so we call that two-tail. So if we were to find that 1.645, all you gotta do is equals norm dot S dot IMV. Since it's two-tailed, you're gonna put 90% plus half the significance, which is 10%. So this would be 0.95, and this will calculate out to that 1.645.
Okay, so if you get a question like this, you're gonna ask us to do.
I will, the question will probably say, give me a 90% confidence interval, here's the information, and also include an Excel equation to find your critical value. That's probably what it will say in the instructions. So you're doing that, but you're adding this equation here to tell me how you got that 1.645.
What about the other Excel we were talking about?
The confidence, the one with the word confidence?
Excel?
You still worried about that?
Yeah.
Wait,
Serious,
Professor,
you guys? Where did that black pen go?
Professor, is it norm SINV or norm INV?
Norm dot S dot IMV.
But you can use the other one, right?
Yeah, you can use any of the other ones. At the beginning of the semester, I think we talked about 5 different ones, the RT, remember that, with the right side and stuff? But this is all you need. So these are the ones I really focused on from week 4 forward, are these right here. And I tried to stay focused on these, because those are all the only ones you need. Hang on, I'll add that on here. Equals confidence. And then, you guys have to finish from there, I don't remember.
It's equals mean plus minus confidence.
Oh, is it? Darn. Equals mean plus and minus confidence. Parentheses. Is that the one you're talking about? Yeah, so make sure and review that. And I didn't prepare it though.
So if we did that equation on the exam, would we have to write one for positive, one for minus, or could we just write the plus minus?
You can write both plus, minus, and 1. I'm okay with shortcuts, as long as you got both answers.
Yeah, okay.
Yeah, because they're the exact same equation, except one's a plus, one's a minus.
And then for that equation, it's significance and then comma, standard deviation, and then sample size.
This is significance,
Yeah.
for sure?
I think.
Yes.
Not, okay, significance, comma, standard deviation, and then on the end, what's on the end of 1?
Sample size.
What is it?
Sample size.
Sample size? Oh.
I think, wait, like, I don't know.
Too.
Does it how long it's been since I looked at it? That's it, right? No, that's it?
Yes.
But is there any time where it would be double significance? Or is it always just?
No, I don't think so, because we're doing two-tail, and we're getting both confidence intervals, so I don't think you have to double the significance. But, check your notes. Anybody else see those
You
notes?
don't.
This is going back all the way to week 1 or 2,
Yeah, I don't think you do.
but, so I can't remember. Let's go to the next one. So now we're going to slide 18. Whoops. Yeah, slide 18. This is confidence intervals for a mean when the population standard deviation is unknown, because you're being given the sample standard deviation, not the populations. And this is the formula you're going to use. It's the mean plus or minus the critical T, which you're going to use your TINV to find, the sample standard deviation over the square root of the sample size. You do that, and you'll find your confidence interval. A perfect example I found, I searched for an example, I went to and found one. Hang on, I don't want to repeat this, I'm gonna close this. We just talked about this one. Boom. Week 2. In week 2, it was problem number 19A. Where's 19A? Right here. I'm gonna make it bigger. Right there. So, part A, only show your detailed work. Calculate the standard deviation of the sample. So obviously we were given the variance in this question, 33.64, but it was the sample variance. Matter of fact, we could read the problem, but I'd have to go all the way back and find it. So that's 5.8. Use 95% confidence, which the significance would be 5%. Use degrees of freedom, which would be 16 minus 1, there's 15, 16 in the sample size, excuse me. The Excel entry would be the TIMV, 5%, because you put in your significance if it's two-tail, and we're doing a confidence interval, so that's always two-tail. Those confidence intervals are two-tail. So we put in the significance, which is 0.05, and the degrees of freedom, which is 35, and we get, what is it, 2.03. Now, 95% confidence interval, you take 158,000 is the mean, plus or minus the 2.03 that we just found by using TINV, times the standard deviation of the sample, 36,000, is that right? 36,000, divided by the square root of 36, which is the sample size. You do all this, you'll get the lower one is 145,820, the upper one's 170,180. The point is, this is an example where you're using T instead of Z. You're reading the problem, you're recognizing it's asking for a confidence interval, and you say to yourself, it just gave me the sample variance, or the sample standard deviation. Confidence interval is going to be one of the first 3 weeks. You find the equation, which is right here. You got, whoops, come on. Slide 18 written down. Oh, there's the equation. You're going, okay, which example should I look at to refresh my memory how to get this started? Do a confidence interval where I'm giving the sample standard deviation. And you're going, oh, week 2, problem 19A. That will refresh your memory, and then you attack this problem. Once you recognize what kind of problem you have in front of you, it's just a matter of going to, okay, what's the formula for that problem? Where's the example for that problem? Refresh your memory, now attack the problem. That's how I would study. That's exactly how I study. Any of these, any of you can do. If I handed you one of these problems and I said, here's the equation to use, every one of you would ace it. It's a matter of figuring out which equation is the right equation to use. That's the hardest part.
Variance wasn't mentioned on part of this.
No, you had to switch the variance to the standard deviation by square rooting
But it wasn't.
Oh, what was the problem? What was it then?
It wasn't.
Was I reading a different problem?
You're reading 25, yeah.
Oh, okay, hang on, let me go back to 19.
We had to do that with like.
I was looking at 25?
Quiz 2 or something.
Oh, and then I was doing 25 all the way down here? Darn. Let's get back to 19. Okay. It is variance. Why would I square root it then if it wasn't variance? 33.64 equals 5.8. So then we put in 5, 16, 15's the degrees of freedom. 2.131 is our critical value. Then we have 48.68 plus or minus 2.131 times 5.8 is our standard deviation of the sample, because the variance. If you go back and, has anybody got the book with them? They can go back and look at 19A from chapter 8, right? Chapter 8. Then you'll see the variance must have been given at 33.64.
Yeah, it was given. It was like,
So here's our upper and lower. 45.59 is the lower, 51.77. Confidence
variance-
intervals, we're going all the way back to week 1, 2, and 3. Go ahead, what were you gonna say?
the variance was given 33.64, and then we square rooted to find the standard deviation of 5.8.
Yeah, that's my example. 25 is a perfect example also, just a coincidence, I accidentally read it instead of 19A as I was saying these answers, but they're both examples of the same thing, same problem. Okay, now, the third one, are you ready? The third one you could recognize. You're looking at this problem, you're going, it's asking for a confidence interval, there's three choices, either the population standard deviation is given, or the sample standard deviation or variance is given, or, we're going now to again, slide 26 is the important slide, or it's gonna be a proportion. There's no standard deviation, it's a proportion. So many out of so many, or maybe it's given to you as a percentage, or something like that, but it's a proportion. And this is the proportion formula right here to do confidence interval. This, I believe, there was only 3 equations when it came to doing a confidence interval. So that's all you gotta say to yourself. Now you gotta say to yourself, do I have the population standard deviation, do I have the sample standard deviation, or is there no standard deviation in this problem is asking for a confidence interval? If so, it's the sample proportion plus or minus critical Z times the given proportion times 1 minus the proportion over the sample size. You gotta square root this whole thing though. So order of operation is 1 minus the proportion, then multiply it times that same proportion, divide by the sample size, then square root it, then multiply times Z, then add and subtract it. I've picked a problem as a perfect example of this. And that happens to be, where is it? Oh, week 3, problem 39A. Whoop, let me get this off here. Week 3, problem 39A. Let me make it bigger. We're reading the problem, we realize it said 50 out of 80. And there's no standard deviation in the problem at all. And we're going, oh, this has got to be a proportion. So 50 divided by 80 gave us our proportion of 0.625. Then we plugged it into the equation once we got our critical Z. Critical Z, norm. Uh-oh, I'm not using the S. We still haven't gotten to S by this week. What week is this? Week 3, we didn't go to S till week 4. Norm, it should be norm S dot IMV. Wait, is this, see, this isn't the critical. If we were to use critical though, this is how, what's our confidence, 95? So we would be equals norm dot S dot IMV. We gotta use 95 plus half the significance because this is a confidence interval, so it's the same as being two-tailed. So 95 says to be 0.975, which would then give us 1.96. So now we do our confidence interval, 0.625. Here we go, where is it? Plus and minus the square root of 0.625 times 1 minus 0.625 divided by the sample size of 80. Anyway, 39A is your example of using proportion, and so is, look down here, here's another good example of proportion right here. Is it? Yeah. 0.47, we've got our whole margin of error on the right side here, 0.031, then we add and subtract it to 0.47. Look how many times 0.47 is used in this equation. We're putting it on the left side to add and subtract from it, and then you have 0.47 here and 0.47 there. So once you have that proportion, whether it's given to you or you gotta calculate it, like on this problem 39B, 30 divided by 80 gave you the proportion, 0.375, and that's how you got it. So now that pretty much finishes confidence intervals. Let me look. And from weeks 1, 2, and 3, there were 3 confidence intervals, 3 equations, but then we went to determining the sample size. Go ahead.
We're gonna need to know minimum sample size.
Yeah, that's what I was about to talk about. Is that what?
Well, no, I was just gonna say, in relation to T and Z, you were saying like if there's no period between what the, like the.
Are you talking about the
standard
Excel
deviation,
equation?
What's that?
The Excel equation?
No, I'm just saying like for identifying, like if it's a Z or T, I have a note that says like if the standard deviation is in the same sentence as the sample mean, then it's.
Yes, you gotta, some of those sentences are kind of tricky on trying to determine whether you're reading a population or a sample. You almost, if it's tricky, almost 90% of the time, there's probably a sample. Because when it's giving you the population, it's usually pretty clear. and the population standard deviation is. So more or less, if you go, wow, this is tricky, it's in the same sentence with the sample mean, you can pretty much assure yourself that it's probably the sample standard deviation you're being given, not the populations. The population standard deviation usually is much more clear in the sentence that it's trying to give you the populations. So that'd be my hint on there. Let's talk about those sample sizes. We're going to slide 33 from chapter 8. Here's the first determine the sample size. There's for the mean and there's for the proportion. So there's two equations involved in sample size calculation. This is where you're given the amount of error. I'll tell you the problem, but first I want to tell you the equation. Let me start with, once you do this whole equation and you get a number like 19.25 here, what do you do next? I want to see if you know the end.
Round up.
Round up, very good. Round up. That's the key part to start with. Number 2, this is your z, whatever the confidence is, you're going to find your z, or the z is given. This is your standard deviation. You're squaring the standard deviation, you're squaring the z, and whatever amount of acceptable error that's in the problem talks about with 2%, or what is this, with an error of 2 or an error of 3 or something like that, that gets squared also. So I'm going to give you an example now. That's for a mean. Wait, let me show you the other equation before I give you an example. The other equation, where is it? Oh, did I skip it? Where's proportion? This is proportion. The other equation is proportion. Again, it's z squared and the e squared. The difference is you don't have a standard deviation. You're instead taking the proportion times 1 minus the proportion here. No squaring. 1 minus that proportion times the proportion. Right there. Z squared, e squared. That's the sample size for a proportion. So those are the two formulas. Now, let's get to the example for the mean. Here's the mean formula again. And the example I'm using right here on slide 35 says, hey, the standard deviation is 45. The sample size, what's the sample size needed to be within plus or minus 5? There's the error. But be within plus or minus 5 is within that much error, 5, 90% confidence. You gotta have to use Excel, 90% confidence to find it, or use the table with 90% confidence to find 1.645. Don't forget, this is considered like two-tailed because you're finding the sample size, but it's during the confidence interval, so you know it's two-tailed. So you would have to use, what's the significance or confidence? 90. So you would have to use 90 plus half the significance. So this would be 0.95. Does that sound right? I believe to get that 1.645. Check it. Check me if I'm wrong. Let me know. And then you got to remember to round up. This is if it's a mean, and this is the kind of information you get right there. The standard deviation, what the amount of error, acceptable errors, plus and minus, and what the confidence is. And that's all you need to get this one. You got to convert the confidence to a critical z.
What were you just talking about with the Excel?
To get that 1.645, you got to take the 90% and turn it into 645 by using Excel, or you can use slide.
Oh, to find Z.
Yeah, to find z. Or you can use, whoops, where's that slide? I just brought it up a little bit ago. Here it is. Slide 12, go to 90%. There it is, 1.645, right there, 90%. Okay, I don't think there's an example for this other one. Let me look. Hang on, determine sample size for proportion. Where's proportion? Determine sample size, that's that one. And here's proportion, and there's, oh, here we go. How large is the sample size? This is a proportion now. Proportion, defective, large population. We're within plus or minus 3%. There's the error. Plus or minus 3%. I think we gotta convert it to a decimal though, don't we? Yeah. Convert it to a decimal, 0.03, and it will be squared in the denominator. There's the error. 95% confidence. And it says, assume a pilot sample yields a proportion of 12%, 0.12. Whatever proportion is being given to you is the proportion you're using in the equation. 1 minus 0.12 times 0.12. So here it is. 1 minus 0.12 times 0.12. There's the error, 0.03, 3% squared. And then, what was it, 90% confidence? 95% confidence, 0.196 squared. We looked up 95% confidence. If you decide to use that table on slide whatever it is, 12 or 18, to write down that you use table from slide whatever, and 95% confidence is 1.96. when you're having to do sample size.
So we can have a table, or are you giving us the table on the exam?
No, there's no table to use. Either you're using the Excel formula, or you can use this,
Okay, sweet.
or just this slide right here. If I'm not giving you a table, but if you wanna download a table off of Canvas, you're more than welcome to. But I think I very rarely even showed you guys how to use the table. Cause we were so focused on using these defining critical values and these equations, I think. Good.
How do we know if it's one tail or two tail?
Well, for all confidence interval questions are gonna be two-tail, and all questions asking about the sample size number will be two-tail also. Assume two-tail, if it's asking for the sample size, assume two-tail if it's asking confidence interval. That's all two-tail. Good. Wait. What?
So two-tail so the first 3 weeks of class, we did two-tail only?
It's always two-tail because it was confidence interval,
Oh,
so you're
okay.
doing the upper and the lower.
Also, I just wanna make sure of something. When you're finding the optimal sample size for the mean, the E is a whole number. You keep it as a whole number?
Yes, if you're using the mean, it will say plus or minus 3, plus or minus 5, plus or minus 10. You keep it as a whole number. It's
And then
not
proportion-
being given to you as a percentage. It's being given to you as a number of units.
And then proportion, you make it into a decimal?
Yeah, you gotta make that one into a decimal. 3%, you gotta make that 0.03 to square it then in that formula. Same with, if I would've said, what if this would've said, assume the pilot sample yields 12% proportion, you gotta turn that to 0.12 also. Turn them both into decimals.
You said all confidence intervals are two-tailed, does that include like the later equations we do?
No, just the first 3 weeks, the confidence interval questions are always two-tailed, because it's asking you for both the upper and lower, so that's what makes it two-tailed.
So how do we differentiate between like asking for some confidence interval?
Asking for a hypothesis, it will specifically be saying, what is the confidence interval, will be a confidence interval question. Just like the homeworks are asking for specifically, what's the confidence interval? The hypothesis ones are asking, there are hypothesis questions asking you to use the confidence interval approach, but that's not a confidence interval question. It's just asking you to use that approach. You could be a one-tail or a two-tail, so you gotta be careful there when you're using the confidence interval approach. That's where we're heading. All right, so we finished everything that was before quiz 1 now, and we're heading now to right after quiz 1, we got into hypothesis testing with one sample.
For the required sample size, like the examples are slides 35, 38, and 39.
35, 38, 39 is samples of what? Say it again.
Like 35 is an example
Of using the mean to get the
Yeah.
sample size. That is slide 35, you're right.
and then 38 is a proportion, and then 39.
38 and 39 are an example of a proportion finding the sample size, yes. Yes.
Oh, those were the only
Everybody hear
ones?
that? Those are the perfect examples.
And just those?
Just those.
Okay.
That's it. We may have had an in-class on this, but I couldn't find it on the homework. Or I don't remember if it was on the homework. Okay, that's it for chapter 8 PowerPoint. We're going to chapter 9, part 1 PowerPoint. I don't know, let me close this, let me close that. Look at us. What's this? Here it is, chapter 9, part 1. We started with hypothesis testing. Are you sick? Are you sick? Oh no. Oh my God. Where's my mask? Hey, can you skip the final? Is that what you just said? You get me sick, well, I'll skip the final. Where was I? One-tail hypothesis, or one sample hypothesis testing. Either the standard deviation is known, or the standard deviation is unknown. Oh, and then there's, what's the other one? Proportions, right? Is that it? So, where are we starting here? This is one sample hypothesis testing. Go to 14, here's our first formula right here, right? Doing a Z because we were given the standard deviation is known for the population, not the samples, we're given the populations. We know this is a hypothesis test, so we know to use Z, and here's our formula, Z, get our test statistic. Once we get this test statistic, which is the mean, or the sample mean minus the hypothesized mean over the standard deviation, the population standard deviation, divided by the sample, square root of the sample size. Once we get that test statistic, we then can turn it into a p-value to compare to the significance, or we could use the significance to get a critical value to take this test statistic to determine if it's inside or outside, closer or not closer to 0. You know, we have all kinds of options, but there's the key formula. Again, this would be one sample, hypothesis testing, and you're given the population standard deviation. Here's an example. The example I have here is from week 4 homework, number 13A. Week 4 homework, 13A. Let me make it bigger. Here it is. The problem says that the sample gave us a mean of 13.4. What we were expecting was 12.6 over the standard deviation of 3.2 divided by the square root of 25. Our sample size was 25. We do all the math on that. Our test statistics, 1.25, a positive 1.25. Now, you may be asked to use the critical value approach, you may be asked to use the p-value approach. You needed this value for either one of them, and it looks like we're doing the p-value approach. So, here's the formula. We're using the top one because the bottom one, wait, was it positive 1.25 or negative? Oh, the wrong one's on here. Oh, then I subtracted from 1. Because I didn't use 1 minus right here, in week 4 I didn't use 1 minus in front, I had to subtract from 1 once I got the answer here. Norm dot DIST 1.25 comma 0 comma 1 comma 1. We got a p-value, but we had to subtract it from 1 because it was a positive 1. We didn't put the 1 minus in front of the norm dot DIST. So we end up getting 0.1056. The significance is 10%. Since 1.56 is greater than 10%, we do not reject. Be prepared. The only thing that's not on our homework that could be on the exam, a question just like this, is that it may ask you to give a 1 sentence to put what it means to do not reject the null hypothesis. Does everybody know what I'm talking about? That you go back and say, therefore, we do not have significant evidence that blanky blank 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 blank, put a blank to blank blank, 12.5. That kind of sentence. That's the only thing that could be added to this. We didn't learn how to do those sentences till we got to 2 samples, but we can apply it back to this 1 sample. I just delayed teaching it so. All right, next. What if instead we could be given the sample standard deviation with hypothesis testing instead of the population? So we're going to slide, hang on a minute. Oh, we're not going to slide anything. We're going to the next PowerPoint. Let me see, is there an example in here too? Is this an example also? No. Oh, right here, here's another example. Remember 3 TVs? We're trying to test whether there's 3 TVs. So we get a sample of 100 people are chosen, and we're gonna use 5% significance, and we're assuming the population standard deviation is 0.8. So here's a perfect example. Our sample came out at 2.84. We thought there'd be 3 TVs, so we subtract, we get negative 0.16. We divide it by the standard deviation of the population, 0.8, over the square root of the sample size, 100. We get negative 2.0. We compare negative 2.0 to our critical Z of 1.96. Since 2.0 is outside 1.96, we do have evidence to reject. In this case, we do have evidence to reject. Therefore, I'm going to write the sentence now. We just rejected. 2.0 is outside of negative 1.96, farther away from 0. We reject the null hypothesis. Therefore, we have evidence that there isn't 3 TVs in the average of 3 TVs per household, whatever the sentence said, in U.S. homes. So it's not equal to 3. Our alternative came true. We rejected the null. The alternative is we have significant evidence that tells us that the average amount of TVs in U.S. homes is not equal to 3. We rejected that null hypothesis. All right. Now we're going to PowerPoint chapter 9, part 2. This is if you were not given the population standard deviation, but you're given the sample standard deviation, 1 sample hypothesis testing. Here's the formula. We're calculating T this time instead of Z. Everything else is pretty much the same, except This isn't the population standard deviation, this is the sample standard deviation. Sample mean minus the hypothesized mean over the sample standard deviation divided by the square root of the sample size. Gives you your t. We can use that test statistic t to either use the p-value approach or the critical value approach. A perfect example, and I gotta find my example. By the way, this is chapter 9, part 2, PowerPoint slide 10, around 10. We're gonna go ahead and use week 5. So this is from week 5. And problem number 35A is a perfect example. Let me find 35A. Here we go. We were trying to hypothesize whether 50 is the mean or not. We did a sample of 16, and the mean came out to 46. So 46 minus the hypothesized 50 over the sample standard deviation is 10, square root of 16. The sample size was 16. Our t, our test statistic t, is negative 1.6. We plug that in, we find our critical t, 2.131 plus or minus, using TIMV. And by the way, look at TIMV, and look how it says 5% there. And notice here it says 5% significance, and 5% under there, 15 degrees of freedom. My question for you is, was this a one tail or a two tail? Why do you say one tail? Notice that the significance was put in there and not double significance. Since the significance 5% was put in there, it makes it two tail. You can tell just by looking at this answer that this was a two tail problem, because it wasn't double. That would have been 0.10 if it was a one tail. Since negative 1.6 is inside our critical 2.131 plus or minus, we cannot reject the null hypothesis. Therefore, the mean is around 50. We have found evidence that the mean is around 50. We couldn't reject the null hypothesis. Our hypothesis mean was 50. That's why we got it on the right side of the numerator here. Okay, now that was if we had one sample, hypothesis testing, and we were given the sample standard deviation, not the populations. That's why we use that equation. And week 5, homework problem number 35A is our example. Now, we're going to slide 16. Same PowerPoint, chapter 9, part 2, slide 16 is all about proportions. This is where you aren't given a standard deviation in the problem. You're going, oh, there's no standard deviation, but there's 16 out of 50 or whatever it says. You're going, oh, this must be a proportion. And the problem says, here's the deal. You got to know that there's two proportions here. This P is the sample proportion. That little symbol there to the right is the hypothesized proportion. So it's the hypothesized proportion that's part of the denominator. That hypothesized proportion times 1 minus the hypothesized proportion divided by the sample size, square root the whole thing. Then you divide it into these two being subtracted. The only time you're using the sample proportion is on the left side of that numerator. Anytime you're doing proportion, when it was confidence intervals, whether if it's one sample hypothesis testing or two sample hypothesis testing, if it's a proportion, you're always using Z, period. Gosh, I almost put a multiple choice question on there too that said, if your problem is a proportion, and then the multiple choice was you're using T, you're using Z, there was something else, and I thought, yeah, that's too easy. I can't put that on the final. That would have been way easy, right? You guys would know. It doesn't matter if I was asking for a confidence interval proportion or a one sample hypothesized proportion or a two sample, you would know to use Z because any types of proportion, Z is the deal, not T. All right, so here's an example. The example I wrote down is from week 6. From week 6, let me close this. And it's problem number 1. Problem number 1, let's see. Write your Excel function equation, the result, find the p-value, 5% significance. Can you reject the null hypothesis? In order to test the population proportion from 38%, you draw a random sample of 100 observations. You obtained a sample proportion of 0.43. The sample is 0.43. The hypothesized is 0.38. So here's the null hypothesis. The proportion is 0.38. The alternative, the proportion is not 38. The 3/8 has to be on the right side, the 3/8 has to be all the denominator in this problem. 0.43 minus 0.38 divided by the square root of 0.38 times 1 minus 0.38 divided by 100. That whole thing gets you your test statistic, which is your z, 1.03. Then you use 1.03, it's a positive, so look at how we put a 1 minus in front. We're finally got to where we stuck with these 5. Finally in week 5 forward, we stuck with these only. We said, heck with all the rest of the Excel equations we experimented with. These are the ones we stuck with. We're using 1 minus because our test statistic was positive. Since it was a positive 1.03, we got 1 minus norm dot distribution, 1.03, comma 0, comma 1, comma 1. Now, this was a two-tailed test, so we had to take this 0.15, multiply by 2 if two-tailed. Listen, you guys, I put this up here in at least 3 or 4 different lectures. And this is the key to getting the Excels right. There are these little, right here. If it's positive, use that one. If it's negative, use that one. Multiply by 2 if it's a two-tail. Drop the negative symbol if you're doing T. One tail, use confidence only. If it's two-tail, use confidence plus half significant. All these little notes is how you'll get all the Excel portion of this exam correct. If you have this down, I'd have this right, boom, right in the corner of my screen right there. All right. Anyway, problem 1 is the one. Multiplied it by 2. Now you compare it. 30.26% or 0.30 is much greater than 5% significance, so we cannot reject the null hypothesis. If there were a story up here, the instructions might say, give a sentence that, to describe what it means to reject or not reject. In this case, because we can't reject, it means we do not have evidence, whatever the story is. That the proportion is not different than 38%.
So, you told us that we have to do like the hypothesis testing, like if it passes under the test.
What do you mean?
Like,
oh, the sentence I keep telling you about?
No. There was something you said where we have to do it before we actually do the equation. Where we have to test if it.
Oh, no, you're going, she's talking about when we have 2 sample testing, and they're both, and we have the sample standard deviation. We don't know which equation you use, I think, because
It was for
and then
this.
we'd have to do an F test to then determine which equation you use. I think is that what
No,
you're
it was
saying?
for this where it's like greater than or equal to 5.
Oh, for proportion. I didn't include that. Does everybody know what she's talking about? It's the NP and 1 minus. It's the sample size times the proportion has to be greater than or equal to 5, I think, or 5%. 5%?
No,
5, okay, 5. And sample size 1 minus the proportion also has to be greater than or equal to 5. Thank you for reminding me. I should put that on the second half. What? Seriously, that's a great question. Sorry, where's my pen? I don't want to forget this moment.
Do you tell us when we have to do that, or do we have to do that all the time?
You don't have to do this all the time. I would instruct you to do this. This would be a question all on its own, I think. If I were to ask you to do this test. Everybody understand what we're talking about?
What's it called?
It's called whether you can use a proportion Z test, I guess, whether it meets. Matter of fact, let's go to the PowerPoint. Here's where it's described. Right here. Hang on. Boom, boom. Right here is a perfect example of where we're checking. It's the what's the word to describe it? I can't think of the word right now. Hang on. I don't see the word. It's right there on the right. But here's a perfect example. You ready? In this particular example, the sample size is 500. The percent, the given proportion is 8%. So 500 times 8% is 40, which is greater than 5. But both of these have to be true at the same time. So 500 times 1 minus 8%, which is 92%, is 460, also greater than 5 or equal to. They're both true, so this will allow us to go ahead and use a test statistic to find whether we can reject or not reject. I'm not going to ask you to do this. If I want you to do this, though, I'm going to ask it as a separate question all by itself. Can you use, a test statistic, proportion, whatever, you know, check and see if the sample size is big enough that you can even use proportion, might be the question for this. Everybody hear that question? Everybody hear it?
Doesn't only one.
Good.
Doesn't only one need to?
No, both. They both have to be true, not one or the other. They both have to be true at the same time. All right, so now we got one last PowerPoint here. Let me close this one, which is chapter 10, 11. In this case, there were several equations we had to learn because, yes, we did these variances, and we'll talk about this in a minute. Yes, there were proportions, which you know is Z. Related samples. Remember where the samples were the same people before they went through some kind of training, then after they went through, the same employees. Related samples is that one. But this one, independent samples, we had like at least, I think, 3 equations, didn't we? Independent samples, but we have the population standard deviations. Then there's independent samples, but we have the sample standard deviations, but maybe the population ones are equal, assumed equal, or we have 2 independent samples, but we have the sample standard deviations, but we assume the population standard deviations are not equal. Remember, there's 3 different equations there. That's kind of the tricky part. And I said to you on the final, I said, if you have to use, let me get here's the 3 equations. If you realize you're being given the sample standard deviation, you don't know which one of these equations to use. For quiz 3, I think it was, I said, go ahead and use this equation unless it specifically says, assume the population variances are equal, or the population standard deviations or variances, whatever the word is, assume the populations are equal. If it says those words, you know to use this equation. But if it doesn't say those, use this equation. But then I said for the final exam, the real way you're supposed to decide which equation to use is an F-test. Do you remember that? All right. I already wrote the first half, so you do not have to do an F-test. The rule that we had for quiz 3 is the same rule for the final exam. If it's this one, if you have 2 samples and they're independent, they're not related, they're not proportions, 2 independent samples that you're going to do hypothesis testing with, and you have the sample variances or standard deviations, the sample standard deviations, you're using this formula unless it also says, and by the way, the population standard deviations are assumed equal. Then you're using this one. Does everybody hear that? Same rule as quiz 3 for the first half of this exam. Probably the second half too, so just assume that unless I announce differently. So now, what is the difference between these formulas? Let's start with the top one. The top one's easy. You realize you got 2 samples there that you're doing hypothesis testing. Not 1 sample with a hypothesize, but 2 samples. And now that you have 2 samples, you're going, oh, these aren't related, they're not proportions, they're independent. They're 2 independent samples. Now, which equation I use? Let's start with the top one. You have being given the population standard deviations or variances that you can turn into standard deviations. Then your equation is right here. Where does it come on? Right there. Assume this is 0. Remember, I kept saying, just assume that 0, take that right out of there. For this whole time, this is going to be 0. So really your equation is the sample mean of one minus the sample mean of the other divided by the variance, that squared means variance of the first one over the sample size, plus the variance of the second one over the sample size. Square root the whole thing. There's your equation if you're given this. Again, this is 2 samples to do hypothesis testing, and you're given the population standard deviation. There it is. It's pretty easy. That one's easy. It's the other 2 where you got to look at it and you got to go, okay, wait a minute, I got 2 samples here. They're not related, they're not proportions, so it's one of these 3. I don't have the population standard deviations, I got the sample standard deviations, so now it's one of these 2. Does it say anything about assume the population variances are equal or not? If it doesn't say anything, then I know it's the bottom one. Go ahead.
Does it always specifically say population standard deviation, like it's worded, or do you have to do so?
Same way it's worded for confidence intervals and the same way for 1. The wording's tricky sometimes, but usually it's pretty obvious when it's the population standard deviation being given to you. The sample sometimes is tricky because it's in the same sentence with the mean, the sample mean. You're going, wait a minute now, is it giving me the sample standard deviation because it's in the same sentence as the sample mean? Same situation we just talked about before. You can kind of assume if it's tricky that you're being given the sample standard deviation because population standard deviations are pretty well announced. And the population standard deviation is type of thing.
So you said, we don't have to use the F-test, we just assume it's not some label?
Yes, if
For
it,
both parts, or just the first part?
well, I don't know what you mean by both parts. You're
Just the
looking,
exam.
yeah, for both parts of the exam at this point.
Okay, so we don't need,
No, F-test, we're still gonna study it, because there's gonna be a question about it all by itself, not related to these though. I thought I was going, I figured too many people would get it wrong if you had to figure out which one of these to do based on an F-test, I don't know. And then do the equation, that's a long problem, it's a lot of points, so I had to break it up into parts.
So for F-test, it would just be kind of like a problem of us showing our understanding of it?
Yes,
There was something so.
and interpretation of it.
There was something so.
Does that make sense? All right, so, and now I want an example of this one for you. The example I have is from week 7. Let's open it up here. Week 7, and it says answer D. What do you mean D? So there's only one question on here, and there's all different parts to it? Yeah, okay, here we go. Okay, look at how obvious this is giving you. First of all, it's obvious this is 2 samples. Sample mean of 1 is 25, the sample mean of 2 is 29. So you're going, okay, here's 2 samples. It's hypothesis testing with 2 samples, but there's 3 they look independent of each other, but which equation I should use, there's the other hint. Population standard deviation for x1 is 9, population standard deviation for x2 is 8.5. Boom. You know it's a z, you know it's that first equation because you're being given the population standard deviations. That's it. And sample size for 1 is 30, 32. D, give your calculations for the test statistic. Go down to D, perfect example of that equation we just talked about. 1 sample mean, 25, minus the other sample mean, 29, over the square root. Look, I gave you the standard deviation 9. You gotta square it, because the formula says use the variance. I didn't give you the variance. I had to square that 9 to turn it into a variance. Over the sample size 30, plus 8.5 squared. I gave you the standard deviation, but the formula says use the variance, so you had to square the 8.5 over the sample size 36. There you go. You get your test statistic, everything's the same from there. Okay, so there's that example. Perfect example if you're given the population standard deviations and you have 2 independent samples that need hypothesis testing. Now, next, 2, hang on a minute, I want to go way through it. Slide 8. We're on slide 8. Slide 15. Here we go. This is, you have 2 independent samples. You're going to do hypothesis testing with 2 samples, but you're not being given the population standard deviation. You're being given the sample standard deviation. But there's a sentence that says, assume the population variances are equal, or the population standard deviations are equal. Don't forget, standard deviation, variance, they mean the exact same thing. One's just the square root of the other, that's all. If that's the case, that sentence exists that says the population variances are equal, then you gotta use this formula, which includes a pooled variance. A pooled variance. This whole thing right here, sample size minus 1 times the variance from 1, plus sample size number 2 minus 1 times the variance for number 2, over sample size 1 minus 1 plus sample size 2 minus 1. You got all this goes right there in the formula. 1 over the sample size, 1 over the sample size. Again, ignore this right part. This is a 0. That's a 0 on the right. 1 sample minus the other sample. There's that formula right there. It's a T, not a Z, because we have sample standard deviations. Where's the example? The example I have is from week 8, problem number. Here's our example. Week 8, problem number 4. Does that say 4A or 1A? Oh, 1A. Okay, here we go. Consider the following hypothesis and data drawn independently from normally distributed populations. Show your detailed calculations. The null hypothesis, mean number 1 minus mean number 2 is equal to 0. The alternative, mean number 1 minus mean number 2 is not equal to 0. 1 tail or 2 tail? 2. Very good. Sample 1 mean is 269, sample 2 mean is 249, sample size 1 is 10, sample size 2 is 10, sample 1 standard deviation, right there. Sample standard deviation, didn't say population, sample. 2 independent, sample standard deviation being given to you. 35, sample 2 standard deviation, 23, those are the samples. We're doing A, right? A, here we go. A says, all right, you gotta do that pooled variance. Then you gotta do that whole thing. 10 minus 1, 35 squared, plus 10 minus 1, 23 squared, divided by 10 plus 10 minus 2, I combined them. 8 gives you 877 pooled variance. Now you plug that 877 into the equation. 269 minus 249, divided by the square root of that 877 we just calculated, times 1 over 10 plus 1 over 10. Each of them had 10 in the sample size. Anyway, A is the example, but hang on a minute. Look at this. B, or this, is almost the exact same thing, except there's nowhere is the sentence. Let me repeat this. You got 2 samples, they're independent, they're not related, they're not proportions, 2 independent samples. You're given the sample standard deviations, but nowhere is that sentence that says the population variances are equal. Doesn't say anything, so you assume they're not equal. So you're using this equation, which is on slide 23. This equation. Again, this right side of the numerator is 0, just ignore it, that's a 0. One mean minus the other mean over the variance of the first one over the sample size of the first one plus the variance of the second one over the sample size of the second one, square root. That equation is so easy because you don't have that pooled variance. The weird part about the second one is though your degrees of freedom. Remember this? Where's it at? There. So be careful. If you recognize this problem, odds are there's an extra sentence that probably gives you the degrees of freedom. Instead of me having you do all of this and showing this work, spending all that time, it'll probably give you the degrees of freedom.
What about the pooled variance?
Pooled variance you will have to calculate, because it's not that hard. If she's saying if it's the other one, the other equation, she's saying if it's this equation right here, you gotta do that pooled variance. What was the other question? Did you, someone say it? No?
No, I was gonna say, or it would be like a separate question, to figure out how to degrees of freedom.
Or it would be, but I'm gonna give you the degrees of freedom. So that's the big hint there.
I have a question. So, are they all gonna be scenarios? Like, are you gonna have scenarios for all of them? Are they all gonna be stories? Or are you gonna sometimes tell us the mean is this, the sample? Because you did that in previous quizzes.
Yeah, it could be either way.
Okay, so you're not just.
Here's the deal, if it's a story, in hypothesis testing, I probably want you to do that last sentence, where after you either reject or not reject, you're telling me what it means.
Okay.
Because I want you to relate it to the story.
But you're also gonna give them to us for some of them, right? We're not gonna have to read like just a bunch of little stories or like scenarios, right?
What do you mean?
Because on previous quizzes, like I would kind of saves time. Like you would put
Yeah, like this, you're saying, like this, hang on a minute.
you would just give us
Like
the
this,
you would
right
give us
here,
the
instead, look up here, there's
Yeah.
no story here, I'm just giving you the information.
exactly yeah.
Yeah, some questions will be just like this, and some questions will have a story.
Okay.
Most likely, the reason I'm giving a story is because I want you then to relate, I want you that last sentence to relate to the story.
And in the first 3 weeks, we're not doing stories, right? You're
No,
just gonna tell us.
confidence intervals
Because-
usually don't have stories.
Yeah,
I mean, it could, but
but don't.
it'll be clear that I'm just asking for a confidence interval.
Okay.
All right, so the example for this one is B. B, and if you notice on B, on the same, again, I'm on week 8, homework answer, part B, number 1B, I think it's called, number 1B. The difference is, this question said now, pretend that the population variances are not equal. So in this case, you had to get your degrees of freedom. Look at the degrees of freedom. 15.55, but look at all that work to get to 15.55. Then you round up to 15 degrees of freedom. Then the formula is easy. You plug it right in. You had to have the degrees of freedom 15 to get your DIST 1.51, your test statistic, comma, 15 degrees of freedom, comma, two-tail. Now you compare that to 10% to get your p-value. But I will give you the degrees of freedom. And you know what? On this problem up here, if A, there's no reason to have degrees of freedom, but I don't wanna give away that you don't need the degrees of freedom, so I'll probably give you the degrees of freedom on that one too, even though you don't need them. Because you're doing Z instead of T. All right. So now we're going to slide 29. Oh, we're out of time. We're out of time. Wow. Real quick, I was going to show you this formula. Here's the deal. Notice I passed up this formula on slide 27 because when we talked about paired samples, related samples, I said you don't have to do Z. All you got to learn is this T. This T right here. All right, so there's the formula for that one. And write down, this is slide 29. Here's the homework problem I was going to show you. Week 9, homework problem number 1 is related to this. Related samples, doing T. Homework problem number 1 for week 9. Next, slide 36. There's the proportion, 2 sample proportion formula right here. Right, and the example right next to this one, right, slide 36, example, week 10, homework problem number 1. Week 10, homework problem number 1 is a perfect example of doing 2 sample proportions, and either rejecting or not rejecting. And then last but not least would be, don't forget this equation right here, which is your F for the variances, which we would use this to determine which one of those independent hypothesis questions to use. But again, this would be a separate question on the exam, not something you have to do and then do a hypothesis testing. Any questions?
It's gonna be like the Excel that you showed us, right? So study the Excel.
When you say studying Excel,
Like
you
that,
mean-
when you do F test, you have to do it on Excel.
Oh yeah, was that test we did using Excel? But I think we did it manually, didn't we?
No, you said you weren't gonna, you
Okay,
said
just
you're not
using
gonna
that
give it to
test
us
on Excel
manually.
then, yeah. If that's all it is, then that's it. But it's how you analyze it, that's the question. What
which
does it mean
equations?
to interpret it? Let me turn off this video so I make sure we got this.